Thanks for the Professor Eva to introduce. Um, uh, okay. It's my pleasure to have a chance to illustrate and introduce our work on ACM Multimedia 2020. This is a joint work with Professor Yunchao Wei and Professor Yi Yang. Our paper's title is University-1652, a multi-view, multi-source benchmark for draw-based geolocalization. Since I want to catch the people's eyes, so I just named the topic as draw is coming. And maybe first of all, I'm a final year PhD student advised by Yang and Dr. Liang Zheng. I'm currently I'm looking for the postdoc position, and if there is any chance, just let me know. That's for yet. And let's start it. First, I just go to the Amazon Australia to check the draw's price. Since our topic is about the draw, actually the commercial draw is relatively cheaper than the GPU servers. So I think it's a chance to ask the supervisors to buy some for data collecting. Yeah, maybe later. So the first question is, what can draws do and why we should study draw? Actually, draw is a new area platform which could collect the data from, from the air. So it could enable several tasks such as accurate delivery, like sending masks in such a pandemic, time. And it also could help agriculture and help the event detection like traffic jam. So this is our motivation to study the draw, collected data. So in this, actually in our paper, we study maybe one basic application. It is called geo-localization, which intends to match the data from two different platforms. You may just see on the left, I provide one ground view imager, and on the right, I provide one satellite view imager. And the geolocalization need to match the two images. However, it is quite challenging since the ground view imager only contains limited roof, while satellite view imager contains whole roof. But satellite view imager also contains the GPS tag. So if we want to use the ground view imager to search the satellite view imager to obtain GPS tag, it is quite challenging since there is a large visual gap between the two data collected from different platforms. So in our paper, we just noticed when very straightforward idea is the draw can be a bridge. We notice actually from left to right, the ground view imager shares some part with the draw view imager, and the draw view imager shares some roof with the satellite view imager. So in this way, we could associate the three kinds of data. And finally, we could obtain the GPS tag in the satellite view imager. But however, there is no data set to verify our idea. So to verify our idea, we just propose one data set, and which is currently missing in existing works. So we collect one data set called University-1652, and we collect the data from three platforms of about 1,000 buildings, and we provide more training data, provide more viewpoints, provide more intra-class variance compared to the CVUSA and the CVACT datasets. And actually, I have discussed with my supervisor. I say I just want to build one data set, but my supervisor said it's too expensive to annotate our data, you know. But you know, just like the comic shows, actually we collect the data, collect the draw satellite and the ground view data from the internet. So my supervisor just agree with this idea, and yes, so next I just do the data collection. And first of all, I collect the data from the Wikipedia. I collect about 1,600 building names from the Wikipedia. Most of them are collected in the in the campus, because we do not want the landmarks, since the landmark is too significant, is too discriminative. It is quite different from our daily life. So we collect the building mostly in campus, in school. So I think we think it is it is quite close to our daily life, quite close to the daily delivery demands. So next, after we get the building names, we just we can search on the Google Map to obtain the latitude and longitude of the building. Here I show the two buildings of UIUC, and yeah. After we get to the GPS, the accurate GPS location, accurate GPS location from Google Map, well, we could collect the draw view data just by setting a moving a flying camera around the building. So we just set the simulated draw view camera as a flying around the building and progressively close to the building. So we could collect quite diverse and from different distance from the different viewpoint of the target building in the draw view. It is really like the real draw collected data. And next, we also collect the ground view data from Google Map. We just set several different points on the street and to collect the image, collect the photos of the building from different orientation from the different position. We also collect the satellite view data from Google Map. Actually, if you are familiar with the Google Map, they also provide the satellite view data. And for every building, so in this way, for every building, we collect the satellite view data, collect the ground view data, also collect the multiple draw view images. And finally, we also add some noisy ground view data from Google Image. We just search the building name and download the image from the Google Image. And I write a script to do that. So it's we also remove the indoor images. If we search the building name, we also obtain many indoor images, and we also remove the duplicated images. And finally, we propose a baseline to verify our idea, to verify the effectiveness of the proposed data set, and we do some experiments. The baseline is quite flexible, quite strong, and it is easy to re-implement. Actually, we just use my last work on ACM-TOMM to enable the learning from the different view. The different view data do not share the backbone, but they share the final classifier. In this way, we could ensure the final feature share one feature space. So we can matching the feature in the feature space. If you have a new data collect from the new platform, we just need to add one new branch. So our baseline is quite flexible and could apply to different environment. Okay, so we use this baseline code to verify different data sets. We also verify our baseline on CVUSA and beat certain CVPR 2019-2018 papers. And we also verify the transfer learning results on Oxford and Paris. Actually, our data set get quite good results. And since our data set is large, so the scalability of the model landed on our data set also performs well. And here we just show the ground view data. The draw view data is better to matching with the satellite view data. Just as I show, since the draw view data share more roof, something like a roof area with the satellite view data. So the draw view matching is quite easy, and it verify first our idea on the associating the data from 3 platforms. And we also ask the someone fly the draw at the UIUC, and we ask the owner to provide us some real draw data he flight, and we also do the search, and we show the learner model on our data set also performs well on the real world scenarios. Yes, it also shows the scalability of our model. And finally, we also provide some ablation study on different loss functions, whether shared weights of the backbone and the different input size of the different images. And yes, if you are interested in our results and more details in our experiment, you may check our paper for more detailed illustration. And I think there are several ways to do more works on our data set. For example, actually we run a leaderboard, and you are welcome to push your results to our leaderboard. And we also do, we have do several work which is based on LBP, local binary pattern description. And this paper is submitted to TCSVT, and we think it's just under the major revision. And yes, we think it is also a potential way to combine the traditional method with on our data set. And I also checked the several traditional key point matching methods. SIFT did not work very well, but we think maybe more other deep learning method could help and could do better on our data set. Thanks a lot, and you may download our data set and code by scan the QR code. And yes, and I may answer one question, which is asked by many people about the data license. Since you may notice our data is mostly collected from the Google, and actually we carefully check the data license of Google. There are 2 main points. First, the data of Google Map and Google Earth could be used based on fair usage. So we follow the guideline on their official website to collect the data and distribute the data. And the second is several existing data sets have also used the data collected from Google. So in practice, we also adopt a similar policy of existing data set to release to distribute our dataset based on the academic request. And thanks. Maybe I should check whether there is any questions, or you're welcome to ask me.
Yeah, it is interesting projects to collect the data in such scales. I want to ask, how long do you take for you to prepare such data, or how much effort do you need? I mean, how many manpower do you need to do this?
Actually, I do this. I write the script and to to crop the data from the website. And actually, I write one script, automatic script. So it is it takes about 1 month for me to collect all data, and yeah.
But how can you? I mean, they can also verify the GPS locations by script or by human.
By script.
Okay.
First of all, the GPS we need to manually search the building name one by one to get the accurate GPS, and then we just use the GPS. The GPS is quite accurate, and to locate the buildings, and then we just if we have a GPS, we can do anything to collect the data of the accurate location.
Okay, thank you. Any question from other audience?
Yes, actually, the state of the art performance is not very well. So you are welcome to publish your results and just let me know. Yeah.
So it can be used for the multi-view learning, right? Because you have the data from different view perspective.
Yes, actually, we call the different view is the different viewpoint. We also call this data set is multi-source, since we collect the data from draw, satellite, and ground view. So there is 3 sources, data source, right?
Okay.
And we also think it is possible, it is quite potential to use the draw to send several goals or several masks to rural area. So I think it's quite promising. And several days ago, I just asked some companies. They said that they really has this, this needs to use the draw to send the goals, just like the Amazon. But the Amazon is, they just use in their own company. They do not send use the draw to send the mask to the rural area. So I think it is maybe a potential way to have such an application. Okay. So
so if some student are shy to ask question, you can send some offline question to Zhedong. Okay, thank you.
thanks.